Several hundred million years ago, a large body of water covered Manitoba. This ancient ocean was home to vertebrates, trilobites, and corals. As these organisms died, they settled in layers on the ocean floor, where they became compressed and cemented together, and over millions of years turned into limestone. Whenever find limestone, you also find crevices, tunnels, and caves. A network of caves is formed when acidic rainwater seeps into the terrain of limestone through cracks at the surface and dissolves some of the limestone. The limestone weakens and collapses near the surface and further below, creating a sinkhole or large pits in the limestone. The limestone pits in Manitoba's interior region are like nothing else in the world. What makes this particular pit so unique? Well, one thing, a huge number of snakes migrate to these holes in the ground. If you go anywhere near the pits in the spring or fall, you find the region alive with thousands of red-sided garter snakes. This is where the largest concentration of snakes. Tens of thousands of these snakes congregate at the surface of there each year. They emerge in the spring after spring, with hibernating in what are known as snake pits. In the fall, the snakes return to the pit to prepare for winter. And why are snakes down in the limestone pits? Well, the very little weight dance in the limestone bedrock makes this sort of a native form. Like all reptiles, snakes are ectotherms. This means warm their bodies mainly by absorbing heat from their environment. The pits are the perfect location for the prey-producing snakes because they shelter the snake from winter temperatures and sometimes rain. Animals interact with their environment in a number of ways. For example, by responding behaviorally, physiologically, or by adapting or evolutionary time. The migration of a garter snake to the limestone pit is an example of a behavioral mechanism for dealing with seasonal variations in temperature. Moving to a new location is an animal's quickest response to an unfavorable change in the environment. By gathering in mass below the frost line, the snakes are able to survive the prior winter. Garter snakes have no optimal temperature for physiological function. They can, however, actually survive freezing temperature for a short time, a few hours only, at a temperature like -1 or -2 Celsius. The average they can stay frozen all winter long, but to survive in cold climates, they were adapted to situations like the absurd freezing temperature outside their dens and cold nights in the spring or fall. This ability to endure short freezes will get them through till morning. The beginning of freezing in their body is a physiological response that serves as a signal to the snakes. Freezing tells them to alter their behavior to move and find a warmer place. This physical behavioral response might also be helpful in their winter dance because if then temperature falls low, and instead of being free, it could be a signal for all the snakes to move to deeper, warmer parts of the den. Only marginal minority that are the culprits short term for freezes. Ever 10 years ago, thousands of snakes died when the tornado showered them, when the frost failed during the extended period of freezing temperatures. They are apparently not able to get to lower depths in time.